Right, so I want to go with you over the contents of your kit. Now, I know that most of you are already quite familiar with this kind of stuff. You've seen it before, or probably even done a project this year with some of these elements, but one is never quite sure, and different people have done different things this year. So I will just get a bit of a summary of what you have in the bag, with the hope that we can all be on the same page. So first of all, probably you notice this big bulky element, and what this is a proto board, a solderless proto board. And what this allows us to do is to make connections between elements without having to solder things together. As you can see, there are holes everywhere. The holes are numbered, although it doesn't matter for our purpose that they're numbered, and so there's some kind of coordinate system here going on. But maybe the only thing that really matters is to understand that the rails that are here on the top and the bottom of the image, these rails are all connected like this. So every hole, the red one for example, so every hole in this row is connected with each other. Even though there are separations here, they're all connected to each other, right? And the same is true for this other one. They're all connected to each other, yet they're not connected to the ones next to them. All right, so these connections run like this, and over here they run in the other direction. Over here they run like this. All right, so 6 is connected to 6, 7 is connected to all of them in 7, 8, and so on. But they are not connected to the ones on the other side. So I'll show you a graphic of how that looks like in the slides. But yeah, just so that you remember that the whole purpose of this thing is to allow you to make electrical connections, sometimes using wires like this, that you should have also received in the kit. The way you make an electrical connection is by, I think, let's see if the autofocus does it. Yeah, so as you can see, this cable has a pin on it, and what that pin does is it allows us to create an electrical connection by sticking it in, and then we stick the other end in some other location. Perhaps we want to get power from the red rail, and then we pin it like that. All right, so now that would mean that this hole over here where we just inserted the pin is now connected to that other hole over here, and therefore is also connected to this one, that one, that one, and that one, because all of the rows are connected to each other. So that's the proto board. I already spoke of the cables. You should have received a solid bunch of them, just enough to connect a bunch of things together. They are colored. The purpose of the colors is that you can color code them, so you can say, okay, my signals travel in, I don't know, white cables, and my power is always orange, and my ground is always white. Typically we use red for power and black for ground. But because you probably received an assorted color, then my suggestion is that you just kind of find your own way of doing it and kind of stick to that way of doing it. All right. Next up, you should have also received a USB cable. So that's USB-A on one end. For those of you with the latest flashy Mac, you probably need an adapter for this because, well, that's Apple for you. And this is a USB, micro USB, which is what we stick at the end of the board. Here we have the board. That's how the board looks like, and that's how you stick the USB into the board. All right, so that's the USB cable. And since we now have the board on screen, I'll speak a little bit about this board. I'll show you. Let me show you first. Let's see. I'll put my hand. No, there you go. Hopefully. Well. Okay. So this is a little better. So over here we have the USB connector that you use to plug to your computer. This other black thing over here is a JST connector, which plugs to a battery. For example, if you want to make a portable or a wearable project, you can plug a tiny battery to it, and then this whole thing can run on a battery. This is called the Featherboard HUSA 32, The model I'm showing you now is a little older, but the one you will receive in the kit will probably be the latest and greatest. And what I want you to do really carefully, and we will do that in the next section, is to really investigate this board. See what all the parts are. Many of them you will not immediately understand, but that's okay. But perhaps the most important thing is that you see the inscriptions there. So each one of these labels belongs to each one of these pins, naturally, as you would expect. And they have cryptic little names on them. But some of these names will become quite important. Now, I will share a graphic with you that tells you a bit what each one of these pins does. But I would like you to turn the board around, look at this side, and spend a little bit of time trying to get familiar where things are. So you can look at symbols such as GND, which stands for ground. That's going to be very important. Another one, okay, let me stand up, that is going to be very important is this one that is called USB. We're going to use that to power our servo motor, and there are a few of them numbered. I think that the numbers are also visible on the other side, so that's 14, 12, 13, etc. So when you get instructions to build a circuit, these numbers will be in those instructions as called pin numbers. Now, the board you have received probably looks a little bit different than this one in that it has stacking headers. So this one comes with these things you see here, these headers. And what these headers allow you to do is to basically just, again, I know that this is obvious to many of you, but I just want to make sure that we're on the same page. It allows you to stick them on the board like this. So if you press down, that thing is now part of your prototyping board. And that means that when I plug a cable next to a specific pin, like for example over there, that's the GND, that's a pin labeled as GND over there. I'm not sure if you see that in the image, probably not, but you can trust me on this one. It says GND, so that's a ground pin, and because this one is connected on the same row as this one is connected, that means that these two cables, so this point and that point, they are electrically connected, and therefore is electrically connected also to the other end of the same wire. So that is a way of taking a connection from here to somewhere else in the board, and that's what we do when we, for example, pin it there. So now this row over here will be connected to that pin in our prototyping board, in our controller. All right, so that's the why and the how of this thing. I'll share a graphic that lays out all the pins and will allow you to look things up while you're making, so that you don't have to decipher every single little thing here. I'll share that next. I'll continue with the explanation of the elements. Together with this, you should have received these three tiny things. Now, mine have already been used a few times, so I cut off. Let's see if that focuses. Yeah. So this is called a resistor, and what this does is it makes sure that you don't send too much power to some specific component. So it allows us to regulate just how much power flows into a specific component. Now, this is not so important for you to learn in detail. This is more like an electronics thing, but just so you know, a bunch of components will need a resistor, and I gave you a bunch of them on the kit that we can use. But yeah, most of the time you will need something like this for certain components, but it's only when you read the instructions of the component that you will learn the actual value of this thing. Now, the value is indicated by the colored bands that you see over here. These colors are actually encoding the value. In this case, this is a 10K. I happen to know that. It's not like I can read this. I normally have to look up the color codes, but you know, real pros, they can read them directly. But this is really easy to look up on the internet. So if you want to look at resistor values and color coding, you can search on Google and you will find a little tool, web-based tool for sure, that will tell you what, you know, you will enter the the colors here, and it will tell you what is the actual value of that thing, of that resistor. And you should have received, I don't know, somewhere between 3 to 6 of this. we will use them for things such as LEDs, etc. They're relatively cheap things, so it's okay. And then you have received probably 3 of these things. Now I'll show you what these look like. Let's see if I can put these in my hand, and yeah, if the autofocus does a good job here. Let's see. No, yeah, okay. That is kind of it. Yeah, right. So that is called an LDR, or a light dependent resistor. That's the fancy way of saying that this is a light sensor. So what this does is it takes the light level immediately surrounding the sensor, and it turns that into an electrical signal that the microcontroller will turn into a number. So this is a sensor. It's just a light sensor, and you have 3 of these. Now, light sensors, they have these 2 really long legs, as you can see, and it doesn't matter which way you connect them. They are identical on both ends, and they are not sensitive to polarity swaps, so they are fine and safe to use. I really like these kind of sensors. They are super basic and super cheap, but I love how many applications and how many interactions can be designed with such a thing. I will run you through a bunch of my ideas about this a little later in another video, but yeah, I'm just running you through the kit now, so I will not go into further details. But you should have 3 of these at least, and these are going to be quite handy. These are analog sensors, so they tell us not if there is light, yes or no, 1, 0. That would be a digital sensor. It tells us more or less how much light it receives. So if you have little light, it will have a lower reading. If you have a lot of light, it will have a higher reading. So they are what are called analog sensors. All right, so that's another bit of our kit, and I believe that the last bit of the kit will be this little fellow here. What this is it's a servo motor. What a servo motor does is it can wiggle around this top part over here. I'll bring it a little closer to the camera, so that's how it looks sideways. And here, this is the shaft, and this shaft rotates when you send instructions to it. So you can say, hey, shaft, rotate 45 degrees to the right, or rotate 90 degrees to the left, and it basically provides you a rotary motion that is easy to control in angles, etc. These are used for RC cars, for example, to turn the wheels around, and they have millions of applications. Actual real cars also have servos in some parts of their architecture, but this is a tiny one that we use. This runs on 5 volts. I'll show you how to power it in another video, but yeah, this is the little component. Maybe pay a bit of attention to this. Is the connector of our servo, and as you can see, it has 3 wires. One will be the ground, the other one will be power, and the other one will be the signal. The signal is basically how you send instructions to it. So you say, hey, little servo, I want to turn to the left 90 degrees, and that travels through one of the wires. Not all of them 3, only one of the wires. The other 2 are used for ground and power, which is the standard. Let's say in electronics, everything has a ground and a power, because that's how you flow current through things, how you send electricity to them, so to speak. All right. So yeah, that's the servo. That's the last part of our kit, and I think this concludes this little video. I'll see you in the next one.